Let's consider some questions on dimensions. The first one is give the dimensions of the following. We have A, acceleration, B, force. So we're asked to give the dimensions of acceleration, B, force. Now, let's begin with that of acceleration. We have A, acceleration. Now, don't forget that we gave hints in our last video on dimensions that whenever you are asked to write the dimension of any quantity, you must always write the formula of that quantity. So the formula for this acceleration is the same thing as change in velocity over time. And then if you observe, you will see that velocity too is a derived quantity, so it also has its own formula too. Velocity is the same thing as displacement over time. This is the formula for velocity. So therefore, what it means is that we must replace this change in velocity with this before we have this time. So we can also write the dimension of velocity first, so that we can replace it here and write that of time, and then we have our dimension for acceleration. Now, we know that displacement is the same thing as distance in a specified direction. Distance is also the same thing as length. So displacement here will stand for L, and then one of the hints we gave, we said that L is what stands for length, and then we said anytime you have distance, you replace it with the letter L. So we have displacement, which we say is the same thing as distance, represented with the letter L, the capital letter L. And then over time, we said time is a fundamental quantity, represented with the letter T. And so therefore, we'll have that the dimension for velocity here will be the same thing as L T. This is dimension for this. This one simply stands for L times 1 over T. And you know, 1 over T is the same thing as T raised to the power of minus 1. So we have gotten the dimension for velocity. That is this. So we can now say acceleration. Dimension for acceleration is the same thing as L per T over time, which is T. So we can now have that this is L T raised to the power of minus 2, because this one, because we know that LT minus 1 is dividing T, and this is also the same thing as L raised to the power of minus 1, LT raised to the power of minus 1. We change this one, this is also the same thing as T over 1, and you can have this as T raised to the power of minus 1 times 1 over T. And you know this is the same thing as minus 1 times T minus 1. So we can have LT minus 2, because the same alphabet are multiplying each other, so we add the quantity. Minus 1 plus minus 1 will give us minus 2. So this is the dimension for acceleration. Let's look at that of force. Now, force is given as mass times acceleration. And don't forget that mass is a fundamental quantity, and we say represented with the letter M, represented by using letter M. Now, so therefore, our force is equal to, instead of the mass, we write capital letter M times, we have already gotten the dimension of acceleration, which is L T raised to the power of minus 1. So we can now therefore proceed by saying M times this will give us M L T minus 2. So this is the dimension for force. Thank you for watching. Don't always forget to subscribe, to like, and to share our videos.